Welcome to a lesson with Dr. Powell. Let's get some more practice with taking antiderivatives. And we're just doing derivative rules backwards right now. Suppose, for instance, we have something like the cosine of 2x dx. Let's think about what this would be. Well, first of all, notice, just as if you're taking a derivative, this thing right here is not x. There's a composition involved. But maybe we can think a little bit about what usually happens when we do this. So normally, if you had something of 2x, what happens when you take a derivative? The first thing you do is you take the derivative of this thing, right, that you would have. But in this case, we're taking an antiderivative. But suppose we're taking a derivative. We take the derivative of the function itself. We plug in this part, and then we'd be multiplying by the derivative of this, which in this case ends up being a constant. Let's just reverse that process. Well, instead of multiplying last, why don't we divide first? So in this process, think about dividing first, 1/2, and then taking an antiderivative, because reversing the step of taking a derivative. Take an antiderivative, we'd end up getting sine, and then just stick in what's there. Now let's just double check. Let's take a derivative of this. Derivative of sine is cosine. With this thing still plugged in, this constant still there, but then we multiply by the derivative of the inside, which is 2. Well, look what happens. Cancels, and we're successful. And the derivative of constant is just 0. So sometimes, in just thinking about derivative rules backwards, we can kind of get what's going on, even in cases like this. Here's another example. What if we had something like negative 3 over 1 plus x squared dx? There's a couple different ways of doing this, but we could imagine having this, which, if we're familiar with the derivative rules, this is actually the result of taking the derivative of the inverse cotangent of x. Of course, then we have 3 multiplied onto it. So we could say this is 3 times the inverse cotangent of x plus c. However, we could have also noticed that 1 over 1 plus x squared is the derivative of tangent inverse. So we could have said this is the antiderivative of this is simply tangent inverse multiplied by -3, just as you would multiply this by -3 here. Both of these are correct. And the reason why is because of this plus c involved here, this shifting mechanism. This function is actually the exact same as this function if you add it by a constant. There's an identity maybe lurking here somewhere, and the identity is simply if you add a certain constant to this, you end up getting that. The plus c will swallow it up. The moral of the story is sometimes when you're taking antiderivatives, there are many different results that may look completely different from each other, but formulaically, there's identities which actually allow them to be the same if you were to add on a constant. So don't get discouraged if you might get something different than someone else does, because you still could be right. Your antiderivatives could simply be vertical shifts of each other. Thanks for watching.